if Waymo wins this race to level 4, why would they win? What aspect of the approach do you think would be the winning aspect? And if Tesla wins, why would they win? And which aspect of their approach would be the reason? Just building some intuition, almost not from a business perspective, from any of that, just technically.
Yeah.
Yeah, and we could summarize, I think, maybe you can correct me, what one of the more distinct aspects is Waymo has a richer suite of sensors as LiDAR and vision. Tesla now removed radar. They do vision only. Tesla has a larger fleet of vehicles operated by humans, so it's already deployed out in the field in its larger, operational domain.
Yep.
And then Waymo is more focused on a specific domain and growing it with fewer vehicles. So both are fascinating approaches. Both are, I think, there's a lot of brilliant ideas. Nobody knows the answer. So I'd love to get your comments on this lay of the land.
Yeah, for sure. So maybe I'll start with Waymo. And you're right, like both incredible companies and just a gigantic respect to like everything Tesla's accomplished and how they pushed the field forward as well. So on the Waymo side, there is a fundamental advantage in the fact that it is focused and geared towards L4 from the very beginning. We've customized the sensor suite for it, the hardware, the compute, the infrastructure, the tech stack, and all of the investment inside the company. That's deceptively important because there's like a giant spectrum of problems you have to solve in order to like really do this, from infrastructure to hardware to autonomy stack to the safety framework. And that's an advantage because there's a reason why it's the 5th generation hardware and why all of those learnings went into the Daimler program. It becomes such an advantage because you learn a lot as you drive and you optimize for the best information you have. But fundamentally, like there's a big jump like every order of magnitude that you drive in numbers of miles and what you learn. And the gap from really kind of like decent progress or L2 and so forth to what it takes to actually go L4. And at the end of the day, there's a feeling that Waymo has, there's a long way to go. Nobody's won, but there's a lot of advantages in all of these buckets where it's the only company that has shipped a fully driverless service where you can go and you can use it, and it's at a decently sizable scale. And those learnings can feed forward into how to solve the more general problems.
And you see this process, you've deployed it in Chandler. You don't know the timeline exactly, but you could see the steps. They seem almost incremental. The steps.
It's become more engineering than totally blind R&D.
Because it works in one place, and then you move it to another place, and you grow it this way.
And just to give you an example, like we fundamentally changed our hardware and our software stack almost entirely from what went driverless in Phoenix to what is the current generation of the system on both sides, because the things that got us to driverless, even though it got to driverless at way beyond human relative safety, it is fundamentally not well set up to scale in an exponential fashion without like getting into like huge kind of scaling pains. And so those learnings you just can't shortcut. And so that's an advantage. And so there's a lot of open challenges to kind of get through, technical, organizational, like how do you solve problems that are increasingly broad and complex like this, work on multiple products. But there's the feeling that, okay, like ball's in our court, there's a head start there. Now we got to go and solve it. And I think that focus on L4, it's a fundamentally different problem. If you think about it, like, let's say we were designing an L2 truck that was meant to be safer and help a human. You could do that with far less sensors, far less complexity, and provide value very quickly, arguably with what we already have today, just packaged up in a good product. But you would take a huge risk in having a gap from even the like compute and sensors, not to mention the software, to then jump from that system to an L4 system. So it's a huge risk, basically.
So allow me to be the person that plays the devil's advocate and argue for the Tesla approach. Yeah. So what you just laid out makes perfect sense and is exactly right. There's some open questions here, which is, it's possible that investing more in faster data collection, which is essentially what Tesla's doing, will get us there faster if the sensor suite doesn't matter as much, and machine learning can do a lot of the work. This is the open question: is how much is the thing you mentioned before, how much of driving can be end-to-end learned? That's the open question. Obviously, the Waymo and the vision-only machine learning approach will solve driving eventually, both.
Yeah.
The question is of timeline. What's faster?
That's right. And what you mentioned, like if I were to make the opposite argument, like what puts Tesla in the strongest position, it's data. That is their like superpower, where they have an access to real world data effectively with like a safety driver and a like they found a way to like get paid by safety drivers versus paid for safety drivers.
Yeah.
Right? Like it's brilliant, right?
Yeah.
But all joking aside, like one, it is incredible that they've built a business that's incredibly successful that can now be a foundation and bootstrap kind of like really aggressive investment in the autonomy space. If you can do it, that's always like an incredible kind of advantage. And in the data aspect of it, it is a giant amount of data if you can use it the right way to then solve the problem. But the ability to collect and filter through the things that matter at real world scale at like a large distribution, that is huge. Like it's a big advantage. And so then the question becomes, can you use it in the right way? And do you have the right software systems and hardware systems in order to solve the problem? And you're right that in the long term, there's no reason to believe that pure camera systems can't solve the problem that humans obviously are solving with vision systems. But
question is when.
It's a risk. It's a
big
risk. So there's no argument that it's not a risk, right? Like,
right.
And it's already such a hard problem. And so much of that problem, by the way, is even beyond the perception side, some of the hardest elements of the problem are on the behavioral side and decision making and the long tail safety case. If you are adding risk and complexity on the input side from perception, you're now making a really, really hard problem, like which is on its own is still like almost insurmountably hard, even harder. And so the question is just how much. And this is where like you can easily get into a little bit of a kind of a trap where, similar to how do you evaluate how good an AV company's product is, like you go and you do a trial, kind of a test run with them, a demo run, which they've kind of optimized like crazy and so forth, and it feels good. Do you put any weight in that, right? You know that gap is kind of like pretty large still. Same thing on the like perception case. Like the long tail of computer vision is really, really hard, and there's a lot of ways that can come up. And even if it doesn't happen that often at all, when you think about the safety bar and what it takes to actually go full driverless, not like incredible assistance driverless, but full driverless, that bar gets crazy high. And not only do you have to solve it on the behavioral side, but now you have to push computer vision beyond arguably where it's ever been pushed. And so you now, on top of the broader AV challenge, you have a really hard perception challenge as well.
So there's perception, there's planning, there's human-robot interaction. To me, what's fascinating about what Tesla is doing is in this march towards level 4, because it's in the hands of so many humans, you get to see video, you get to see humans. I mean, forget companies, forget businesses. It's fascinating for humans to be interacting with robots.
Oh, it's incredible. And they're actually helping kind of push it forward. And that is valuable, by the way, where even for us, a decent percentage of our data is human driving.
Yes.
We intentionally have humans drive higher percentage than you might expect, because that creates some of the best signals to train the autonomy. And so that is on its own a value.
So together we're kind of learning about this problem in an applied sense, just like you had with Cosmo. Like when you're chasing an actual product that people are going to use, robot-based product that people are going to use, you have to contend with the reality of what it takes to build a robot that successfully perceives the world and operates in the world, and what it takes to have a robot that interacts with other humans in the world. And that's like, to me, one of the most interesting problems humans have ever undertaken, because you're in trying to create an intelligent agent that operates in a human world, you're also understanding the nature of intelligence itself. Like, how hard is driving is still not answered to me. I still don't understand
all the subtle cues, like even little things like your interaction with a pedestrian where you look at each other and just go, okay, go, right? Like that's hard to do without a human driver, right? And you're missing that dimension. How do you communicate that? So there's like really, really interesting kind of like elements here. Now, here's what's beautiful. Can you imagine that like when autonomous driving is solved, how much of the technology foundation of that like space can go and have like tremendous, just transformative impacts on other problem areas and other spaces that have subsets of these same problems.